All right, gentlemen, welcome to section 8, which is entitled The Octet Rule and Chemical Bonds or Bonding. This section we're going to be talking about chemical bonding. There are two types of bonding that we'll study in this class. The first type is one that we introduced today, ionic bonding. The second type will be covalent bonding, and that's in our next video, so check it out. So the chemical bonding is based on or follows this rule, the octet rule, which we went over in class, which states that atoms are more stable when they have configurations that resemble that of a noble gas, so having 8 valence electrons in their outermost energy level. When an atom reaches this state, we oftentimes say that it has achieved an octet. That's a phrase you'll hear me throwing around, so be familiar with that. Now, what ionic bonding is, it's a transfer. The key word is transfer. And you'll see why when we talk about covalent bonds. So it's a transfer of electrons between a metal and a non-metal. It only happens between metals and non-metals. So that's a key for you, key factor. Metals are the electron donors. They give the electrons away because they have a very low ionization energy. It does not take much energy to take those electrons away. They don't really want them because it will require a lot more energy for them to gain more valence electrons than losing the ones that they have. Conversely, nonmetals are electron receptors. They will receive electrons from metals. Or, more blatantly, they will actually be the takers of electrons. They are what we call electronegative, or they have very high ionization energy, so they hold on to their electrons very tightly, and they don't want to give theirs up, so they end up taking other people's electrons, or other atoms' electrons. People don't have that. Alrighty, so let's do an example. In class we did a few examples, but here's another example between lithium and oxygen. So lithium, as an electrically neutral atom, has an atomic number of 3 from the periodic table, which means it has 3 protons and 3 electrons as an electrically neutral atom, not an ion yet. Oxygen has an atomic number of 8, meaning it has 8 protons and 8 electrons. It is electrically neutral at first. In order to bond ionically, there has to be a transfer of electrons. My metal will transfer its valence electrons to the nonmetal, and the nonmetal will receive them, donor and a receptor. Lithium has 1 valence electron. So Li, with this little dot here, is my electron dot structure for lithium. Oxygen has 6 valence electrons, because it's in group 6A. So if I draw those, 1, 2, 3, 4, 5, 6, that is for oxygen. Now, lithium has 1 valence electron, so it's going to give 1 valence electron. It's going to donate that to the oxygen. When it does so, lithium here loses an electron. So it went from 3 electrons to 2 electrons. In doing so, it becomes Li plus, lithium 1 plus, because I have 1 more positive proton than I do negative electrons. It's 3 to 2. The 3's win by how much? By 1. The difference between 3 and 2 is 1. So lithium becomes Li 1 plus. The 1 is understood to be there. Now, let's look at oxygen. Oxygen just gained 1 electron. In order to achieve an octet, oxygen must reach 8 valence electrons. Thus far, it started with its 6 valence, 1, 2, 3, 4, 5, 6, and it gained 1 from that lithium atom. It's at 7. It's not quite at the level of a noble gas yet. It has not achieved an octet. So what it will do is it will take another lithium atom. You have to keep in mind that atoms never act alone. You're never going to see a single lithium atom and a single oxygen atom reacting. Where there's 1, there are many. So another lithium atom would come along, very much like this one, with 1 valence electron, and it would also donate an electron, fulfilling the octet or achieving the octet of this oxygen atom. So oxygen has gained 2 electrons, so it went from 8 to 10 electrons, and now 10 to 8. 10 overpowers 8, so I have 2 more negative electrons than I do protons, Therefore, my oxygen becomes charged by 2. You represent that as O2 minus. So I have lithium plus and O2 minus. Now, since this lithium atom also gave its electron, we can say that one became the same as this, Li 1 plus. So when I'm explaining this, or when I'm trying to figure out what chemical formula they make, or what ratio do they react in, I can say there are 2 lithium ions, or 2 lithium atoms, for every 1 oxygen in order for it to achieve its octet. So how I write that is Li, 2, meaning 2 lithium atoms for my every 1 oxygen. This would be known as the chemical formula. There's also a way to name this. When I name this, I name my first metal cation as its general name. It's lithium. So I keep it with its name. Lithium. And then here, it's oxygen. I take off the ending and I add IDE because it's a negative anion. That's kind of redundant, but it's a negative ion, which is the anion. Anions always get the ending or suffix of IED. So it's oxide. Lithium oxide. The arrows here, it's called a bonding mechanism. Through this bonding mechanism, we can predict what the formula is and what the compound is. This is the longer way. Understand this and you are fantastic. Now there is a shortcut. The shortcut is called the crossover method. We went over that in class. The crossover method can be done very simply and easily. First thing you have to know is what am I dealing with? I have lithium here with 1 valence electron, oxygen with 6. 1, 2, 3, 4, 5, 6. Since lithium's a metal, I know it's going to donate electrons. When it donates this 1 electron off, it's going to become lithium 1 plus. When this oxygen, being a nonmetal, is going to gain 2 electrons. When it gains 2 electrons, it's going to become O2 minus. Get that in your head. You lose 1, 1 plus. You gain 2, 2 minus. Now the crossover method says if I take my invisible number here, 1 and that 2, and I cross that 1 down to the oxygen here, and that 2 down to the lithium. I don't bring the charges with them. I don't bring the plus and the minus, just the numbers. I get that Li gets a 2 here, and this oxygen gets the 1. In chemistry, we don't write the 1. It's understood to be 1 because there's only 1 atom here. And this formula matches the formula we just did on the other board. This is a very simple way to do that, and we can name it in the same way. It is lithium oxide. So quickly, that is ionic bonding. Stay tuned for covalent bonding. Peace.